right now is the very first time in human history where you can say with a straight face, you may not die.
You believe that?
Oh, there's no question.
What if you could turn back your biological clock by years? What if age reversal is not just science fiction, but something people are already trying? In this video, we explore how scientists are measuring biological age and whether reversing it is possible. We'll take you on a journey from the lab bench to real people trying to become younger on the inside. Imagine this: you are 50 and years lived, but your cells behave like those of a 35-year-old. You walk more easily. Your memory is sharper. Your arteries are healthier. That is the promise of reversing biological age. But how do you know if it worked? That is where measurement comes in. Let's dive in. What is biological age and why it matters? We all know chronological age, the number of years since birth. But biological age is an estimate of how well your body is holding up, how old your cells and tissues really act. Two people both age 60 might have very different biological ages, depending on lifestyle, genetics, stress, disease, and environment. Scientists believe biological age is a better predictor than chronological age when it comes to disease risk, longevity, and how well you age. Over time, various kinds of biomarkers have been developed to estimate biological age: methylation clocks, telomere length, metabolomic and proteomic profiles, and physiological metrics. One of the most widely known is the epigenetic clock, based on measuring DNA methylation. These patterns of methylation change predictably with age, and deviations between predicted age and real age can reflect how fast someone is aging. Another set of measures include metabolomic or proteomic biomarkers, imaging such as brain scans, physiological tests like lung capacity and grip strength, and composite scores. In fact, combining multiple biological age measures may give more robust insights. So when people talk about reversing biological age, they almost always refer to improving those markers, making your methylation age younger than before, improving metabolic biomarkers, or restoring function so your body behaves younger again. Is age reversal even possible? The science landscape, the idea of reversing age might seem fantastical, but science is starting to make small inroads. However, it is early days. Let's look at what has been done so far. In animal studies, especially mice, there have been remarkable results. Some experiments use epigenetic reprogramming, turning on certain pluripotency factors to reset epigenetic marks to a more youthful state. In mice, these approaches have partially reversed signs of aging, improved organ function, and extended health span. Another line is the use of small molecules or compounds that enhance telomerase activity or modulate cell maintenance pathways. Some studies have found that these can lengthen telomeres and reverse signs of aging in tissues. There is also research on senolytic drugs, compounds that selectively remove senescent cells. These are cells that are damaged, no longer dividing, and harmful. Clearing senescent cells may reduce inflammation and age signals. Some studies use plasma fractions or shared blood between young and old animals to rejuvenate tissues. In some cases, researchers observed reversal of epigenetic age, yet translating these to humans is challenging. Safety, specificity, long-term effects, and unintended risks remain big questions. Human trials and lifestyle interventions. Because intense genetic or molecular interventions are risky, many researchers have turned to lifestyle-based interventions in humans, diet, exercise, and stress management, to see if they can push biological age backward. One notable human trial applied a methylation supportive diet, exercise, stress-reducing breathing practices, and other lifestyle changes over 8 weeks. The result was that participants reversed their epigenetic age by about 3 years relative to a control group. Another small trial with women over 8 weeks found that 5 of the 6 participants achieved reductions in biological age ranging between 1 to 11 years from baseline. Then there is the fasting mimicking diet, a 5-day low-calorie, low-protein plant-based regime designed to mimic fasting. In human trials, participants following cycles of this diet showed reductions in insulin resistance, liver fat, immune aging markers, and on average reduced their biological age by about 2.5 years. These results are promising but modest. They show that at least part of biological aging is responsive to interventions, and that age reversal might be possible, but only within limits. How people are measuring reversal in real life. Let's imagine how a person testing age reversal might go about it. Step 1: teen baseline measurement. They collect blood, saliva, or tissue samples and run epigenetic clock tests. They might also measure telomere length, plasma metabolites, inflammatory markers, or imaging metrics. Step 20: intervention. The person embarks on a program such as diet, exercise, stress reduction, perhaps supplements or controlled therapies. Step 30: follow-up measurement after weeks or months. They repeat the same battery of tests and compare. If the epigenetic age falls lower than at baseline, that is evidence of reversal. Similarly, improvements in metabolic biomarkers, reduced inflammatory markers, or better organ function can support the conclusion. Some enthusiasts even test hyperbaric oxygen therapy. There are claims that with certain protocols, telomere length may increase and senescent cells may be reduced, thereby reversing biological age metrics. But here is the caveat: measurement error, natural fluctuation, placebo effects, and regression to the mean make such results tricky to interpret. Also, changing one clock does not guarantee holistic rejuvenation. Some efforts use wearable data to derive a biological age estimate. A new framework calculates age from smartphone or smartwatch data integrating sleep, circadian rhythms, and movement. Thus, people are blending lab tests and everyday health tracking to monitor changes over time. Challenges, doubts, and ethical questions: we must temper excitement with realism. Here are key challenges. Causality versus correlation. Just because methylation patterns change does not mean real aging has reversed. Some scientists argue methylation changes are markers, not drivers. Safety risks. Manipulating epigenetic states or turning on growth or repair pathways could trigger cancer or unwanted cell proliferation. Longevity of effects. Will any reversal last, or will the body drift back to higher age? We don't know. Individual variation. Genetic background, environment, and disease burden may limit responsiveness. Ethics and access. If age reversal becomes possible, who will have access? What are the societal implications of people staying biologically younger for longer? Still, the fact that biological age can be measured is crucial. It gives a way to track interventions and assess their real effect. A story of someone trying biological age reversal. Let's follow a fictional person, Maya, age 52, who signs up for a trial to reduce her biological age. On day 0, Maya gives blood for methylation tests, metabolite panels, inflammation markers, and wears a health tracker for 2 weeks. The results show her methylation age is 57, 5 years older than her chronological age. Her metabolic markers show insulin resistance, moderate liver fat, and mild inflammation. She commits to an 8-week program combining a diet enriched in leafy greens, B vitamins, and whole food ingredients, moderate intermittent fasting, and a few fasting mimicking diet cycles, a regular high-intensity interval training and resistance training, stress reduction through breathing exercises, meditation and sleep hygiene, periodic hyperbaric oxygen sessions. After 8 weeks, Maya repeats her tests. Her methylation age now reads 52, a reversal of 5 years. Her metabolic markers improved, insulin sensitivity is better, liver fat reduced, inflammatory markers are down. She also feels more energetic, sleeps better, and has improved mood. She tells her friends, "I turned back my biological clock." But scientists caution her the sample size is small, there is no control, and there may be measurement noise or placebo effect. Over the next 6 months, they repeat tests quarterly. Some of the gains hold, some drift back. Maya maintains her habits. Over a year, her methylation age is stable at around 53, still better than baseline. Though not perfect youth restoration, Maya's experience suggests that some reversal is possible via lifestyle and perhaps adjunct therapies. But she remains aware. She did not become 30 again. She simply improved her biological state and slowed or partially reversed some damage. What researchers are exploring now? Science is pushing ahead. Key areas include refined epigenetic reprogramming with safer protocols to reset age markers without causing harm, gene therapies to boost repair pathways, telomerase or clear damaged components, senolytic and senostatic drugs to clear senescent cells or suppress their harmful signals, plasma or blood-based rejuvenation therapies to transfer youthful signals, clinical trials in humans to test novel therapies for safety and effectiveness, better biomarkers that combine imaging, metabolomics, proteomics, wearable data, and epigenetic clocks. The field is young. As measurement techniques improve, so will our ability to test whether true age reversal is possible. What you should take away: biological age is a growing field, and it is a way to assess how your body is aging beyond just years lived. Reversal is not guaranteed, but early evidence from animals and humans suggests some aspects of aging are changeable. Lifestyle interventions such as diet, exercise, and stress control currently offer the safest path to improving biological age. Any claims of drastic age reversal should be met with skepticism. We must consider measurement error, placebo, and long-term safety. Measuring changes is essential. Without good biomarkers, we cannot know whether an intervention truly works. If you try to improve your biological age, get baseline measures, plan safe strategies, and retest. Think of it as self-experimenting guided by science. If you enjoyed this video and want to stay updated on breakthroughs in aging, longevity science, and how to live healthier for longer, make sure to hit that subscribe button and ring the notification bell. Drop a comment: would you try measuring and reversing your biological age? What concerns do you have? Thank you for watching. Let's grow younger inside together, one step at a time.